Advanced AI language models. In recent years, there has been an explosion of interest in artificial intelligence, AI, and machine learning, ML, models for natural language processing, NLP. Among the most notable are ChatGPT, Google Sparrow, Google LaMDA, Google PaLM, GShard, BERT, RoBERTa, GPT-2, T5, and XLNet. In this video, we will provide an overview of each of these models, including a comparison of their features, training data, access, how to interact with them, and other important parameters. Comparison. All of these models are based on the transformer architecture, which was introduced by Vaswani et al. In their 2017 paper, Attention is All You Need. The transformer is a neural network architecture that uses attention mechanisms to process input sequences of varying lengths and produce output sequences of varying lengths. This architecture has been shown to be highly effective for NLP tasks and has become the basis for many state-of-the-art models. ChatGPT, GPT-2, and XLNet are all developed by OpenAI, while the Google models, Sparrow, LaMDA, PaLM, and T5, are developed by Google AI. GShard is a research project from Google, but it has not yet been released as a fully functional model. BERT and RoBERTa are developed by Google and Facebook AI Research, respectively. One notable difference among these models is their size. ChatGPT, GPT-2, and T5 are all large models, with hundreds of millions or billions of parameters. BERT, RoBERTa, and XLNet are also quite large, with tens or hundreds of millions of parameters. Google Sparrow and LaMDA are smaller models, with only a few million parameters. GShard, being a research project, does not yet have a definitive size. Another difference among these models is the types of NLP tasks they are best suited for. ChatGPT, GPT-2, and XLNet are all highly capable models that can perform a wide range of NLP tasks, including language modeling, text generation, sentiment analysis, and machine translation. BERT and RoBERTa are primarily used for text classification and named entity recognition. T5 is a text-to-text model that can perform a variety of NLP tasks by converting input text into a text-to-text format. Google Sparrow and LaMDA are designed for conversational applications, such as chatbots and virtual assistants. GShard is a research project that has not yet been applied to specific NLP tasks. Training data. All of these models have been trained on massive amounts of data to achieve their impressive performance in natural language processing tasks. ChatGPT was trained on a diverse range of text sources, including books, websites, and social media. OpenAI trained the model on the web text dataset, which contains over 8 million documents and over 40 gigabytes of text. Google Sparrow was trained on a combination of text and audio data, including voice commands and search queries. Google trained the model on a dataset of over 15,000 hours of speech and over 100 million words of text. Google LaMDA was trained on a diverse range of text sources, including websites, books, and news articles. Google trained the model on a dataset of over 570 gigabytes of text. Google PaLM was trained on a combination of text and image data. The model was trained on a dataset of over 570 gigabytes of text and over 500 million images. GShard was trained on a diverse range of multilingual text sources, including books, websites, and social media. The model was trained on a dataset of over 100 gigabytes of text in multiple languages. One of the most important factors in the performance of any machine learning model is the quality and quantity of the training data. All of these models have been trained on large datasets, but the specific datasets vary depending on the model. ChatGPT and GPT-2 were both trained on large datasets of web pages, books, and other text sources. XLNet was trained on a combination of web pages and academic papers. BERT and RoBERTa were both trained on a combination of books and web pages, but RoBERTa used a larger dataset and a modified training process to achieve better performance. Google Sparrow and LaMDA were both trained on conversations from various sources, such as email and messaging apps. Google PaLM was trained on a combination of books and web pages, but it was specifically designed to work with smaller datasets. T5 was trained on a wide range of datasets, including academic papers, news articles, and web pages. GShard is a research project that has not yet been trained on a specific dataset. Access to these models varies depending on the specific model, the intended use, and the company or institution that developed it. To interact with ChatGPT, users can use OpenAI's API to send natural language prompts to the model and receive generated text responses. Alternatively, users can download and run the model locally to generate text responses. Google Sparrow is designed for voice-based interactions and is currently not publicly available for use or access. In the future, it may be possible to interact with Sparrow through voice-based devices or applications. Google LaMDA is still in development and is not yet available for public use or access. It is designed to be integrated into various conversational AI applications, allowing users to interact with the model through chatbots or other conversational interfaces. Google PaLM is currently only available as open source code, and users can use the code to train their own language models or modify the existing PaLM model to suit their specific needs. GShard is currently not available for public use or access, but the open source code is available on GitHub for researchers and developers to explore and experiment with. Other parameters. In addition to the differences in training data, access, and how to interact, there are some other parameters that differentiate these advanced AI language models. These include pre-training objective. Each of these models has a specific pre-training objective that guides the learning process. For instance, BERT uses the Masked Language Modeling (MLM) objective, where certain words in the input sequence are randomly masked and the model has to predict the masked words. On the other hand, GPT-2 uses the Unsupervised Language Modeling (ULM) objective, where the model has to predict the next word in a sequence. Fine-tuning task. These models are often fine-tuned on specific downstream tasks such as sentiment analysis, question answering, and text classification. The fine-tuning task depends on the specific application for which the model is being used. Model size. The size of these models can vary significantly, with some models having tens of millions of parameters while others have hundreds of millions or even billions of parameters. Generally, larger models tend to perform better but require more computational resources. Latency and inference speed. Another important consideration when using these models is the latency and inference speed. Some models can be faster than others, which is important in applications where real-time responses are necessary. Conclusion. Advanced AI language models such as ChatGPT, Google Sparrow, Google LaMDA, Google PaLM, GShard, BERT, RoBERTa, GPT-2, T5, and XLNet have revolutionized the field of natural language processing. These models have shown remarkable capabilities in tasks such as language generation, translation, and understanding, and have become critical components in a wide range of applications. Each of these models has its own strengths and weaknesses, and the choice of model depends on the specific application and task at hand. However, as these models continue to evolve and improve, it is clear that they will play an increasingly important role in shaping the future of AI and natural language processing. Thanks for watching.